Get rid of the center.
Are you sure?
Okay, so yesterday, remember we were factoring anything that was ax squared plus c equals 0. Okay, so that procedure was to move the c over, divide by a, and take square roots. Okay, which that's good, that works. But what happens if we have a bx term in there? Okay. Because of that bx term, we cannot use square roots now. Okay, so if you were to have something that looks like, let's say 2x squared plus 3x plus 8 equals 0, we can't take square roots now. Okay, because this term throws everything off. Okay, so we have to have a strategy for doing this. Okay, so this section deals with that. And basically what we're going to do, instead of using the square, we call the square root method, what we did yesterday, we're going to use factoring. Okay, but a key concept for factoring is this idea here. It's called the zero product property. Okay, and it says if a times b is equal to 0, if a times b is equal to 0, then what does that tell you? A and b, either one or both of those numbers has to be themselves.
0.
Has to be 0. So if I tell you that a times 5 is equal to 0, you automatically know what a is, right? It's got to be 0. If I tell you 13 times b is equal to 0, you automatically know what b has to be. It's got to be 0, right? So the zero product property basically says if you are multiplying two things together, that's usually what we say, multiplying two things together, but this evolves into basically being able to multiply any amount of things. So it could be a times b times c, it could be a times b times c times d. Okay, you multiply as many things as you want together. But if their product is 0, then that means 1 or 2 or 3 or however many you have, those factors themselves are 0. Okay, or it could be 0. So that's what we're going to use today to help us find these x-intercepts. Okay, it says the number of solutions is consistent with what we explained. I should say section 4.3. But what we did yesterday and the day before. Okay, if we have no real solutions, we're not going to cross the x-axis. If we have one solution, we cross the x-axis one time. If we have two solutions, we cross the x-axis twice. Okay, I would say, if we're going through and kind of tallying the amount of problems that we do, I would say at least 90% of your problems are going to be there. I would say then maybe 6 to 8% there, and then 4 to 6% would be here. Okay, but most of our problems are going to be this situation. Okay, two solutions. All right, so here are the steps. Okay, first thing you're going to do is that you're going to move all your terms to one side. Move everything to one side of the equation, and that will leave you 0 on the other side. Does that make sense? You'll make sure all your terms are combined. So you'll have an x squared term, you'll have an x to the first term, and you'll have a constant. Okay? And then we make sure that we write everything in descending order. Okay? So here it says you can only continue if your equation looks similar to this. Okay? Every problem that you do, you're going to have some quadratic equation over here in descending order, and then you're going to have it equal to 0. If you do not have that, you cannot go on to step 3. Okay? Step 3 says you're going to factor the left-hand side. You're going to factor the quadratic. Okay? And this should say chapter 3 instead of chapter 8. Okay? So in this example here, you guys remember taking and say, okay, if that's x squared plus 5x plus 6, what are two numbers that multiply to give me 6 and add to give us 5, right? Those two numbers are 3 and 2. So then we write this as x plus the 3 and then x plus the 2. and it's still equal to 0. Does that make sense to everybody? So that's where we get that right there. Okay? So as we're working through, first thing we have to do is get x squared plus 5x plus 6 equals 0. You need your quadratic equals 0. Then you factor your quadratic. And at this stage, we can then use the zero product property, which says, okay, remember what x is. X is just a number, right? So if x is just a number, maybe x is 5. Then what's 5 plus 3? If x was 5, 5 plus 3 would be what? So that blue thing there would be 8. What is 5 plus 2? 7. So I'd have 8 times 7. Okay, does that give me 0? No, because it doesn't give me 0, then I know that x couldn't have been 5. Wow. I'm good. I felt like somebody stabbed me in the throat. That was weird. No, I'm good. So we know that x cannot be 5 because when I multiply these two numbers together, they could not give me 0. Okay, so what we do is we use the zero product property and know that this is just a number and that is just a number when you know what x is. And if you're going to multiply two numbers together and get 0, then that means that one had to be 0 or that one had to be 0. Does that make sense? So then, if that's the case, what we do is we create two little equations. Okay? We take the first factor here of x plus 3 and we say, let it be equal to 0. And then solve for x. If I solve that for x, what would x be? Solve this for x. I'll get x by itself. Subtract 3, right? So x would be negative 3, correct? If x was negative 3, plug in negative 3 here to the blue. If negative 3 got plugged in here to the blue, what would that give you that right there? What's negative 3 plus 3? 0. And then plug it into the green. What's negative 3 plus 2? Negative 1. What's 0 times negative 1? 0. And that's what we want, right? So that tells me right there that one of my answers is negative 3. X has got to be negative 3 because that's one of the values that I'm multiply together. Inside here, I get 0. Okay? Now we also take the other product or other factor of my product, x plus 2, and set it equal to 0. Okay? If x plus 2 is equal to 0, then x will equal negative 2, right? If I plug negative 2 in right here, what's negative 2 plus 3? It gives me 1, right? What's negative 2 plus 2? 0. What's 1 times 0? 0. So that's the idea that allows us to find our two answers. That's why, and you're going to find out that this isn't a very strenuous task, but basically we write our quadratic equation, we factor it, and once we factor it, we set each of those little factors, this sets the parentheses equal to 0, and solve those, which should be a one-step equation, two-step equation, and it gives us our answers right away. Okay? And that will then be the place, if we were to graph them, where we cross the x-axis. Okay? So, let's just do some examples here. Okay? This one here, and a lot of these early on, okay, it's missing a parenthesis first of all, but a lot of them early on already have them factored for you. Okay? So right here, we're saying 3x plus 2. It's that, because of the parentheses, when you know what x is, that amount is just one singular number when you evaluate and add 2 to it. Okay? The 5x minus 1, when you plug x in, when you know its value, and you evaluate, that is one singular number. So if I've got a number times a number equal to 0. Okay, so this thing here is a number times a number, and you get 0, then that means this thing here had to be 0. That number had to be 0, right? So I take 3x plus 2, and I set it equal to 0. Or that number right there had to be 0. So I take 5x minus 1, and I set it equal to 0. And once we have that, then we solve those two small I said one-step equation. It could be two steps. You're not going to get anything more than two steps. So what am I going to do here in the red one first? Okay, so we get 3x equals negative 2. Then x will be negative 2/3, right? What do I do here in the blue one? Add 1 to both sides. And then I'll divide both sides by 5. And give me x to be 1/5. And what do we like to always do? Yeah, see if that makes sense. So we had 3x minus 2 and 5x minus 1 was minus 2, or plus 2. Okay, so we've got that. And I want to see, okay, what we're saying then is if x is equal to 1/5, when I put x right there and I put x right there, do I get the 0 that we're looking for? If I plug x to be negative 2/3, okay, I plug that negative 2/3 there and I plug it there, I get the 0 I'm looking for when I multiply them together, right? So negative 2/3 would actually make this. So let's do this this way. So 3x plus 2 and 5x minus 1. So if I look at it this way, I kind of just separate them. So if I plug x to be negative 2/3 into this one, it gives me 0. And when I plug it into 5x minus 1, it gives me negative 4/3. So it gives me negative 13/3. If I take negative 13/3 times 0, which is what is happening right there, does that make sense? Negative 13/3 times 0, well, that gives me 0. So that's showing that one of these numbers was 0. If we would have tried the x being 1/5, plugging 1/5 into this one here gives me 2.6. Plugging 1/5 into here gives me 0. And so up here, I'm actually taking 0 times 2.6, which is still 0, right? That kind of makes sense to everybody? They're both right, okay? And you can't just choose one. You got to have both of them as your answers. So both solutions. Usually we write it this way. We can write, I'll give you a couple different ways. We can write like curly brace, and then we write like negative 2/3, and then comma 1/5, and then a curly brace. I think a lot of times in like Math Excel, if there's multiple answers, I think Maya asked this question yesterday, how do I type in multiple answers? If they want it this, they'll have probably that curly brace already defined for you. So they'll have it written, and then there'll be a box here that you can obviously change things in, and then they'll have that one static as well. But you'll then separate them with a comma. That kind of makes sense? But I'm okay if you just write, or if we're doing this paper and pencil, if you just get those two things and just circle them, I'm okay with that. Okay. Next one. Okay, so this one here, and then this is almost simpler than the last one, but it creates issues for people, okay, because of this x right here. Okay, right now that x is a number. 3x minus 3 is also a number. And if I'm multiplying them together to get 0, that means either the number x was 0 or the 3x minus 3 was 0. Well, this one is already solved for us, right? Okay. What about this one? How do I solve for x there? Okay. So x equals 1, right? So our two answers are 0 and 1. So those are the only two numbers that when you plug back into that expression on the left-hand side, that it evaluates to 0. Is that something we can do? All right, let's, we'll come back to this one later. Do that one on your own. Positive. You done? What'd you get?
I didn't know we were going this one.
I'm done.
So do we set x plus 1 equal to 0? And do we set x minus 5 equal to 0? So this one gives you x to be negative 1. This gives you x to be so those are our two solutions. Is that okay? Questions on this? Pretty simple so far. All right, so let's increase the rigor a little bit. Okay, let's do this. Don't start this one yet. Let me write this down real quick. If we FOIL this thing, do we get x times x, which is x squared? Outside times outside is 7x, right? Inside times inside is negative 3x. So 7x plus negative 3x gives me 4x, right? And then last times last gives me negative 21. Okay, so the blue equation is exactly the same thing as the green one, right? The blue one we say is factored, and the green one we say is expanded. Okay, or sometimes they call it standard form or quadratic form, but they generate the same thing. If I were to graph both of them, just to prove that they generate the same thing. If I graph x minus 3 and x plus 7, and then graph x squared plus 4x minus 21. Okay, does the blue graph and the red graph, are they the same thing when I toggle them back and forth, right? Okay, so these are alternative versions of the same thing. So if they were to start me with the green one, which is what I'm trying to kind of get us to recognize here, this procedure. They're going to start, as we work through the rest of this sheet, these examples, they're going to start us with something looking like a green one, right? Well, that green one, we can take the time and factor that down to the blue one. We should be able to say, okay, well, what two numbers multiply to give me negative 21 and add to give me positive 4? And those are negative 3 and 7. So we write our question we write the x squared plus 4x minus 21 as x minus 3, x plus 7 equals 0. And then this is a number times a number, and we get 0, right? So let's say then x minus 3 should be 0, and x plus 7 should be 0. This will give me x to be 3. This will be x to be negative 7. Does that make sense? And what happens then, let's try this. If I plug 3 in right here, what's 3 squared? What's 3 times 3? 9. Plug it in right here. What's 4 times 3? 12. So I have 9 plus 12. What's 9 plus 12?
21.
And then if you subtract 21, what do you get? You get 0, right? So right there shows you that 3 is a value, is a solution to this equation. If I plug negative 7 in, what's negative 7 squared? 49. What's 4 times negative 7? What's 4 times 7? Okay, so negative 28. What's 49 minus 28? 21. And then what's 21 minus that 21? 0 again. Those are the only two numbers of all the numbers that exist. Those are the only two that when plugged in there give me 0 back. And if we can look at this to prove that. Okay, so I'm going to change this to it just so I can create a slider here. Okay, no matter what number I choose in, so this is taking 1.9 and plug it in here, right? And I get negative 9.79. Okay, you see that a lot of these numbers are not 0, correct? A lot of these results here, when I plug 6 into this, I get 39. But when I plug 3 in, do I get 0? And when I plug negative 7 in, do I get 0? But everywhere else they're not 0. Okay, now let's think about what these mean. Okay, so this is, so I know I'm using A, but that's an x value for my equation. So an x value of negative 7, and then this is a y value of 0. So on our graph, if I plug in, if an x value of negative 7 and a y value of 0, do you see that point right there, which is where we cross the x-axis? That's an x-intercept. So this process that we're going through is giving us these locations of where our graph crosses the x-axis, and those are called x-intercepts. Okay? So let's do this next one. Okay? Now this next one's a little bit different. Okay? Here we have to start moving and merging terms. So I want one side to have everything on it, and I want the other side to have 0. What side here is easiest to make or turn into 0? Okay, so this side, the right-hand side, would be the easiest, right? So how am I going to make that 0? Well, if I did that, think about this. If I subtract 19 there, and subtract 19, is that what you said?
Yeah.
So that's going to give me x squared minus 11x. You subtracted 19 here, so that goes away. And now that gives you negative 24 on the right-hand side. Did that make one of your sides go away? Did it make that side turn into 0?
Why does that have to, can't that happen more within the equation?
I mean,
There wouldn't be an equal sign, so now there wouldn't be anywhere to go across the line. You get what I'm saying?
How'd you get rid of the equal sign?
Because if you subtract, if you have to add 5 to both sides.
Okay, so add 5 there, and add 5 there, right?
Yes.
Okay.
So then now there's nothing on the other side of the equal sign because it's 0.
Okay, but these are numbers, right? So negative 5 plus 5 equals, so that is a thing. Like I can't just, so if it's an equation, there is nothing that you can ever do mathematically that makes the equation disappear. That equal sign will never go away. Okay? So if you start doing operations where one side completely disappears, what that really means is that it has changed to the number 0. Does that make sense? So we do, then that's what we want. We want this to be 0 here. That's the goal for us to progress to the next step. A lot of people, in my experience, struggle. I have a lot of college students right now that struggle with that when they're working on a problem and they make one side turn into the real number 0. They think that means it just disappeared. Okay, that it's nothing. It's vacant. We still need to express that amount. Okay. So now we get to the point where we can factor this. Okay. And the reason we want to do this, and I'll explain this in a little bit more detail in the next step, but it's because there's only so many ways that we can multiply numbers together and get a product of 0. If I don't change that from negative 5, there's an infinite number of ways of multiplying numbers together to get negative 5. Okay, so maybe that we'll explain this here in a moment. But what can I do? I'm looking for two numbers that multiply together to give me 24 and add to give me negative 11. Does anybody know those two numbers? Good. Negative 8, so it's going to be x minus 8. And negative 3, so it'll be x minus 3. Now, because we know a number times a number is equal to 0, that number and that number both themselves could be 0, right?
I'm confused on why you're writing the sign on.
Because I just want us to remember that, and you don't have to write that pound sign. But I'm just trying to get us to remember that it is a binomial x minus 8, but we treat it just like a number, because that's exactly what it is when we know what x is. Okay, so if you say x is 10, then that thing I have highlighted is actually 2, because it's 10 minus 8, right? I just want to make sure that we realize here that we're taking a number times a number, and that's giving me 0. So that's why we set, using the 0 product property, x minus 8 equal to 0, x minus 3 equals 0. So then we get those two values
So we have to write them.
for our answer.
Okay, so we have to write them as that, or do we have to write it as x equals 8 or x equals 3?
Either one's fine. That's fine. Okay. You might see it written this way. They might recall. They might ask you for that in Math Excel. So in Math Excel, they'll say, write your two values for x separated by a comma, and they will already have that curly brace there. And then in the box, you type in your 8 comma 3, and then we'll have another curly brace. So it might be different ways to ask it. Make sense? But those mean the same thing. Those two different versions. Okay, so why do we want this to be 0? So if we were, let's look at something like, let's say I go x squared plus 5x plus 6. Let's say that equals 12. And let's say that we don't make that, we're supposed to make that 12 go to 0, right? Let's say we don't do that. I just want to show you why we have to make this a 0. So if I were to factor this side here, that goes to x plus 2, x plus 3. Would you guys agree with that? And that equals 12, correct? Okay. So then, here's we got a number times a number, and it equals 12, correct? Okay. So so basically what we want to do, we want it to be 0, because that narrows our focus. It says, well, we know that the only way that I get a result, a product of 0, is to multiply by 0, right? That one of my factors has to be 0. Okay. So it narrows my focus on the numbers I can choose. What are some numbers that I can multiply together to give me 12? Okay, so if I let this as being 12, I would say that this number, x plus 2, could be 3, and x plus 3 could be 4. Does that make sense? Or I could say x plus 2 is the 4, and x plus 3 is the 3. Or give me two other numbers that multiply together to give me 12. So I go x plus 2 is equal to 6, and x plus 3 is equal to 2. Or x plus 2 is equal to 2, and x plus 3 is equal to 6. Give me another set of numbers that multiply together to give me 2, or 12. 12 and 1. So I go x plus 2 is equal to 12, and x plus 3 is equal to 1. X plus 2 is equal to 1, or x plus 3 is equal to 12. I know it's getting sloppy, but are there any other numbers? Negative 3, negative 4. Okay, are there any other numbers? Negative 2, negative 6, right? Negative 12, negative 1. Any others? What if I take 24 times a half? Does that give me 12? What if I go 48 times a fourth? Is that 12?
We don't get that spicy one.
But you see that there's ultimately, because I didn't make this value 0, there is an infinite number of different possibilities here that I would have to check and try, and only some of those, only 2 of those will actually work, okay, that makes this true, okay? The rest of them are really going to make it false. But it's going to be very hard to find those 2 by leaving that to be 12. Does that make sense to everybody? So we have to turn that into a 0, and then factor what is left over here. Okay, so that is why we have to make it a 0, because it narrows our field of view on our whole numbers, on which ones that we're gonna work with here. You guys take a minute and do this next one. X squared plus 7x plus 15 equals 5. And after this one. Did you subtract 5 from both sides first? Okay.
So it has to multiply. It has to multiply something to add to 10 to get to 10.
Yep.
And then it has to add to something to get 7.
Yep. So 2 numbers that multiply together give me 10, and then those 2 numbers should add to 7. What are those 2 numbers? 2 and 5. So then we take x plus 2, and that should, because we had a number times a number, and that gives me 0, so x plus 2, that number should be 0, or x plus 5 should be 0. So those are the x values that we're looking at. -2, -5. And we plug those, so that means when we plug back into the original, let's plug -2. What's -2 squared? 4, right? What is 7 times -2?
Wait, what's that? -5.
Because when I set this equal to 0, I solve for x. So this will be 4, this will be -14, right? So it's -10 total. What's -10 plus 15? It's 5, right? Okay, so that -2 will work in that original, and -5 will do the same thing as well. Okay. We'll pick up with that stuff tomorrow. You ever play a game Trouble? Push down on the thing, pop some dice.
That's a fishbowl.
That doesn't do that.
That's a fishbowl.
Fishbowl? Why you say that?
You keep fishing there?